Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed alkylation of isobutane with ethylene using HF as catalyst, industrial alkylation reaction. Moving on to the next step. HF protonates ethylene, H2C is equal to CH2, to generate a carbocation. By Markovnikov's rule, the proton adds to give the more stable secondary carbocation, CH3CH2+. But actually ethylene gives a primary carbocation initially, which is not stable. In the HF-catalyzed alkylation mechanism, HF first generates a small amount of tert-butyl cation from isobutane via hydride abstraction, or alternatively the ethylene is protonated to give ethyl cation which quickly reacts. Moving on to the next step. Under HF conditions, isobutane to methylpropane, CH3CH, CH3, loses a hydride to HF to generate the tert-butyl carbocation, CH3, 3C+. And for the final step, the tert-butyl cation, CH3, 3C+, adds to ethylene H2C is equal to CH2 to give CH3, 3C, CH2, CH2+, a primary carbocation, which rearranges via hydride or methyl shift, or alternatively the tert-butyl cation adds and then the resulting carbocation rearranges. The primary carbocation, CH3, 3C, CH2, CH2+, undergoes a 1,2 hydride shift to give CH3, 3C, CH, CH3, a tertiary carbocation. This tertiary carbocation then loses a proton to regenerate HF catalyst to give the most substituted alkene by Zaitsev's rule, CH3 to C is equal to C, CH3, 2, which is 2,3-dimethylbut-2-Na. CH3 to C is equal to C, CH3, 2 is 2,3-dimethylbut-2-Na, which is a tetrasubstituted alkene. This corresponds to option B, which shows a double bond with 2 methyl groups on each carbon. Why other options fail? Option A 3,3-dimethylbut-1-Na would result from simple addition without rearrangement. The primary carbocation intermediate is too unstable and rearranges. Option C shows a trisubstituted alkene with an H on the double bond carbon, which does not match the expected tetrasubstituted product. Option D CH3CH, CH3, CH to CH is equal to CH2 would be a simple addition product without carbocation rearrangement and is not the thermodynamic product under HF conditions. Therefore, the correct answer is B. Therefore, the correct answer is option B.